Welcome back. Let's check the answer to your last example. The main things to check for are your signs, okay? Check that you didn't miss that you need to factor out a -9 here. And then you end up with a difference of two squares. So you need to keep going with your factoring. And then your final answer is x minus 2 times x plus 3 times x minus 3. Okay. Let's move on. Our last topic for this week is how do I factor the sum and difference of two cubes? Well, we have a formula to use for this, and the formulas are stated in the box below. So if you have a sum of two cubes, so that we have a perfect cube in the first position, a perfect cube in the second position, what we need to do with those two numbers, so a cubed, okay, is we take the cube root of that, and that's a. So for example, if you see the number 8 there, the cube root of 8 is 2. So every time I see the letter A, I would put a 2 in its place. Okay? Likewise, if you see an x cubed in one of those first two positions, the cubed root of x cubed is x. So every time you see the a in the formula, you would write an x. Notice here we have an a squared. If a were 2, we would actually square that and write a 4 there. Okay, so simplify as much as you can. The only difference between the two formulas are the signs. Okay, the way I remember them is the sum of two cubes starts with a sum, a difference of two cubes starts with a difference, and then they both just have one minus sign in them, and that's how I remember. They both add a b square at the end. The proof of this formula is below, or one proof of it. This is a proof of the difference of two cubes, and it's a visual geometric proof. So we have a larger cube and we remove one. So this is in the textbook as well with some more explanation, but I just wanted to put that there, that this isn't math magic, okay? We can prove this. All right, let's start with example A. So, first thing I'm noticing is I don't even see an x cubed. But what I do notice is I have a common factor here. I see that there is an x here, and I could factor an x out of the front. And while I'm factoring out x's, I could probably factor a 4 out of each of those. So let's just double check. 108 divided by 4 is 27. Okay, we can factor out a 4x. And then what I have left is x cubed, and then 27. 27 is a perfect cube. The cubed root of 27 is 3, because 3 times 3 is 9, 9 times 3 is 27. So when I'm looking at my formula, every time I see the letter B, I'm going to put a 3. In the A position, I see an x cubed. The cubed root of x cubed is x, and every time I see the letter A, I'm going to put an x in that spot. So I have the formula memorized. I have it written behind me. I know there's a little bit of a glare, but our formula, let's take another quick peek up here. It starts with a plus b, and then a squared minus ab plus b squared. I can't forget this 4x. That's going to be actually your most common mistake. You'll factor that out and then forget about it in your answer. Okay, a plus b, x plus 3. A squared is x squared minus a times b, which is 3x, plus b squared would be 9. And there we go. Now it's in its factored form. It's always good to double check to see if you can factor the trinomial at the end. You would ask yourself what multiplies to 9 and adds to -3. but in this case, there's nothing. Let's try a few more. I'll switch colors. So looking at our first term, d cubed is a perfect cube. 125 is a perfect cube. The cube root of 125 is 5. So if I take the cube root of this, I have 5d. So every time I see the letter A, I'm going to write 5d. And the cube root of 8 is 2. So every time I see the letter B, I'm going to write 2. This time I have a difference of 2 cubes, so I'm going to start with a subtraction statement. So I'll have 5d minus 2. Now it says to do a squared. 5d squared is 25d squared plus, now I multiply them together for 10d, and then square my b term, which is 4. And there's my factored form. Let's try one more for good measure. I don't see perfect cubes, but I see common factors. So let's start by factoring out a 2x squared. 2 divided by 2 is 1. X to the 5th power divided by x squared is x cubed. 16 divided by 2 is 8. X squared divided by x squared is 1. All right, now I see some perfect cubes here. I know that when I see the letter A, I'm going to put the cubed root of x cubed, which is x. When I see the letter B, I'm going to write the cubed root of 8, which is 2. Don't forget that 2x squared in the front. This is a difference of 2 cubes, so I'm going to start with a subtraction statement, and then I'll use addition for the rest of my formula. So it says a squared, so I'll do x squared, plus a times b, which would be 2x, plus b squared, which is 4. And that's it. I'd say my advice to you is to always write down what a and b are, just like I did in the examples. Additionally, if I'm like kind of rattling off some cube roots and that's not as quick for you, I would make a list. So the way you could make your list would be the cube root of 1 is 1, or 2 cubed is 8, 3 cubed is 27, 4 times 4 is 16, 16 times 4 is 64, 5 times 5 times 5 is 125. So if you make a list of these, it'll be easier for you to recognize them in your homework and on your tests. And I think even by writing them down once, it'll just help you so much, okay? And you probably don't have to go too far. I don't think the numbers get too big, but that's just my advice to you. All right, so let's think about and list some of the factoring methods we've learned so far this year. We just did the sum and difference of 2 cubes. We just did factoring, or factoring, of course we did factoring. Factoring by grouping. We also looked at a difference of 2 squares. We've learned how to factor perfect square trinomials, quadratic trinomials with a coefficient of 1, quadratic trinomials with a coefficient other than 1. We've learned greatest common factor. So we've done a lot of factoring. So this, again, apply these, go back and remember these, check for things as you're factoring using these formulas. Double check for that difference of squares, double check for a perfect square trinomial. And if you have questions, make sure you stop into office hours this week, and have a really great week.